Okay, so it is always good to kind of just take a period to say, okay, we've learned all this stuff. Can we not learn any new stuff? Can we just work with it all? Okay, so you're not going to learn anything new today, which is kind of a nice day, but you're going to have to learn how to differentiate between all those different things, all those different rules, all those weird, like, change this. So here are three things that we did last day. There was the product law. This is on your formula sheet. There is the quotient law, also on your formula sheet. And there's the power law, already on your formula sheet. Now, as a class, can we come up with anything else that we would use, we have learned, rules, laws, anything else? We got lots of room here. Let's write them all down. Okay? Give me what I would write down. Okay, so how would I write that if I was going to write that on my study sheet? Yeah, give me an example with variables in it. I would actually do variables. Log n to the p equals. Okay. Now, we're going to work with logs, and you're going to write a log test. So, it's, ironically enough, you'll probably need your study sheet the least for your unit exam. Okay? Because we've been doing logs. In 3 months, you will be lucky if you remember all these rules. Extremely lucky. Okay? So that's where your study sheet is really needed. Okay? And again, I'll tell you, I have students coming up to me all the time, Mr. I wrote this on my study sheet, but I don't know what this means. Okay? That means you probably wrote it with the assumption that you would not forget this stuff. Or, I don't have to be that clear with this. So you do have to really learn how to make a study sheet. It's not just jam all this information down. It's actually, in 3 months, how will this be useful? So you got to keep asking yourself that question when you're making a study sheet. In 3 months, will I forget this? Yeah, probably. That's a pretty good rule. Okay? Keep going. What else? Okay, good. Log b to the 1 will always equal 0. Can you take log 0? Try that. Log 0 divided by log 8. What is that? Yeah, x can't equal 0, right? Because if you look at your graph here, it cruises along like this, right? I don't think x equals 0 for... Yes? Log b to the b equals... Okay, yes? Log b to the 1 equals 0. What else? Okay, good. Log b to the c equals c. If you did, this would still be a package that could come down in front. You never know. That question. Uh, one class has totally different dynamics to the other class. I mean, they didn't come up with that in the other class, but that comes up in the diploma. And you're like, oh, okay, because that could come up in the diploma, and people are like, what do you do with the D? What do you do with the D? This class might know what to do with the D, my other class wouldn't, right? Yeah. Anything else? Yep. So C log A to the B equals log A, B, C. Okay? So that one's really showing, because you know what's dangerous about this one, this example? People think C can only move if those two are both the same. And that rule that you just gave us helps us to, oh yeah, you can move C anytime. It's just that when A and B are the same, so they'd be AA, you can actually get rid of the entire log, okay? Students make up things all the time and not really tested through. Like, I had a student one, and this is true, like they really showed me how they've always done it, but they would go like 0.8, 35, he would say that is 0.84, right? And he'd get it right, because it's right, if I said round to the nearest hundredth. And when he'd get 0. Say 234, and I said round to nearest hundred, he was getting 0.23, right? It's all good. But it was this time when he was getting 0.235, he was saying that 0.23. And I'm like, yeah, if it's 5 or more, we always round that one up. And he goes, yeah, but it's not. I'm like, what? And it wasn't just a 1-minute mix-up. He'd been doing this his whole time up to high school, and he was getting them right most of the time. He always looked at this number. And if you look at how many times, like if you look in the rest, it was always a coincidence, but 90% of the time he was getting them right. And so he made up this rule, and it was successful for him most times, right? And I was like, hey, no, there's no way. You got this far rounding, looking at the left number. And I looked at even my tests, like most times it would coincidentally work, right? So the rules that are dangerous are the ones that work a lot of the time, okay? But we should probably only make rules that work all the time. Just kind of makes sense. But that is a true story, and I was like, okay, but it shows you how you can get pretty far, sometimes not knowing what you're doing. Okay, let's just do like 3 examples. Now, this one here, it's actually one that we haven't seen before. We did one on the quiz today that had numbers in the front, but they were the same numbers. What do we do when we have numbers that are not the same? How would we go with this one next? Lowest common denominator? But we can't subtract these two anyway because these are not the same. So if we went LCD and subtract, like we're not, if this was log a to the 8 minus 1/3 log a to the 8, LCD and subtract, okay? But because these are not the same, just like on the quiz, you could not go 4 plus 4, okay? You had to take it out. See, this is a good question because it is subtly different and makes you have to really think. Totally different on this one. Okay, so you know what's wrong. Let's try something else. Could you put them on the top? Can you put the 1/2 up here? Yeah. So let's do that. Yeah, what is 16 to the 1/2? 4. Now, when I say these are really, really easy if you know what you're doing, I mean, that's like, okay, whatever. I think that kind of goes for everything. But these are, do you see how easy they are if you knew that? And if you don't know that, you know what I'm going to get? I know I'm going to get 1/2 minus 1/3. I'd probably get, you know, whatever. So that's what? 3/6 minus 2/6. It'd be 1/6 log a to the 2, right? Because they would divide the 69. Like, I know that would be a common answer. But now I got log a to the 4 minus log a to the 2. One little step, and all of a sudden, this is like a very easy question. Now, this would turn into log a to the... Now, let's just do this step. 4 and 2's are very, very confusing in math. You should never use them, right? Because 4 divided by 2 is 2, and 4 minus 2 is 2. And do you see how there's a minus sign here? So I know people would think, like if I just went, so the answer is log a to the 2, I would have some students thinking I got that by doing 4 minus 2. Why not? There's a minus sign in the question before. Okay? So 4's and 2's you should never put in examples, but this one was in the book, so I had to anyway. And if I had to put 32, log a is 32 in there, I think we could do that pretty easily. Okay? So that would be it written as one final log. Okay? Let's go to the next page. We still need to write that down. Okay. Sometimes doing one question different ways is more valuable than doing a bunch of different questions. So I'd like us to get creative here and come up with the answer to this question in 2, 3 different ways. Okay? Anyone got a way they would try? Yes, what would you do? Bring this 3 up. Okay? Okay, well now you're invested here. You got to do the rest for me. Okay? And that would equal 0. Does everybody see that? Okay? Let's do it another way. Bring the 3 down. 3 log x minus 3 log x. Why am I allowed to subtract these? Because they are identical. Okay? Now get that on a study sheet. Can subtract this one. Can't subtract this one because, right? Getting those things down, you will, like right now you're like, I get it. I know it. It's good. Right on. I will get that on the test. And you will. But will you get it on the diploma? Yep. No. If that was 4 log x minus 3 log x, I'd have 1 log x. Okay? What's another way to do this? Yep. Yes, and they are, right? Yeah, it has to be identical. Both A and B have to be identical. Yeah. Okay, could we have brought up the 3's again like we did and done log x cubed over x cubed? Right, we could have. To subtraction you could divide. What does that equal? Log 1, which equals 0. Okay, what's another way we could have done this one? We're not going to do B or C. Yep, so we got room there. Okay, so I'm going to put 3 times log 1 equals 3 times 0 equals 0. Now, no, bring it on. I don't have an equal sign though, right? No, you know that. Yeah, I needed to know that.
Please excuse the interruption. Any students wishing to see the Grant McEwen representative, please go to Mrs. Neidham's office now. Again, that's any students that want to see the Grant McEwen representative, please go to Mrs. Neidham's office.
Okay, what do you want to do? Yeah, okay. Too bad I recorded that. But okay. Anything else? Yeah.
So you did three, so it's x to the third, and then you have a negative 1 in front on both, and with the subtraction and the negative, it ends up being positive, so you have positive 1 log x to the third.
You wanted to bring this up here?
What? Sorry?
You wanted to bring that negative up there? Is that what you wanted?
Yeah, you took that, you flipped it.
Everything.
Yes.
Well, you can't do that.
Just the 3, so it's the negative 1, and then you bring that over to the front. So it's negative 1 log x to the third.
Plus
Plus,
log.
yeah, plus log x to the third.
Okay, and what do you want to do? What did you want to do after that?
That will, that equals 0.
Yeah.
I told you a whole lot of stuff.
I thought you had reciprocals going in there or something. You said
Well, no, you,
that's not a reciprocal. You changed the order.
No, it's x
so it's the reciprocal.
to the 1/3.
That's right.
See,
Like x to the 1/3.
right? So actually, this isn't a bad way. I like this. Watch this. See? Hey, this is cool. This is a good one. Look at this. Is that not right? What I did there? Brought the negative up. This would now we multiply, don't we? What do you do with exponents when you multiply? You add them, so it'd be x to the 0, which is log 1, which equals 0. No, that's awesome. That's a good way to do it. I like that one. I went to this conference last year, and what the Chinese do the best on test scores in the world, and the Americans are one of the lowest. But they also asked the Chinese, do you think you're smart? And most of them said no. And when they asked the Americans, do you think you're smart? All of them said yes. Okay? And here's the other thing, though. The United States has like 99% of the patents in the world. China has none. Right? And it's like Americans have so much confidence that they're always thinking outside the box. They're not into test scores. They're not into rote learning, but they're into, that kind of thinking. And it's valuable because like Google doesn't hire people that can do tests really well. They want people who can think outside the box, who could do, and they were saying that it's hard to put, people who are really, really smart and they can do higher management because they're not good at the skills that takes, right? So, if this kind of thinking wasn't around, we'd probably be doing the same stuff we were doing 100 years ago. Okay. Now this one here. We Josh, can I get going here? This one here was another adventure that we had in the other class. So I want to do this as a class. And if you give me a step that is correct, we're going to go with it. Okay? I will not lead you down a road of that's incorrect, let's keep going, okay? But I want to see if you got this on the diploma. Now remember, the more questions you do, the more familiar you're going to get with these. And when you write a diploma, you're going to be like, oh, I remember that one. Yeah, we did one just like that one. But what if you get one that you actually have to just think? So this one is one of those. How would we pull this off? I need to know what log 2 of 16 to the x squared is. Or no, 16x squared. And they do tell me that log 2 to the x equals a. How would I do this one? Okay? Okay. So, we got 2 to the a equals x. Christine's saying this, let's put it in there. So, this would be log 2 16 to a squared. Okay? Does that make sense? Now we got to simplify it, because that's not simplified. You cannot multiply 16 times 2. It's held captive twice. Because that's not a 2. That's a 2 to the a. And then that's 2. Like, you can never multiply. You can multiply that. You're good there. That's 3a squared. But then if it was 3 times, like, a, right, you can't go 3a squared. That'd be 9a squared. We don't want that. This would be 3a squared, right? Okay, so we want to go log 2 of 2 to the 4 times 2a, or 2a to the 2. That's what you wanted? Okay, that's the correct step. You cannot bring the 2 down with so you just want to bring the 2 by itself. Like you want to bring this down here? Is that what you want? Oh, okay, I'm with you. Okay, so we want log 2 to the 4 and 2 to the 2a. Mm-hmm. You can't just take some of the exponent, right? No, but that would be just some of the exponents. You'd have to take them all. Okay, now if I took it all down, what would it look like? Yeah, I have to take the entire third level, not just parts of the third level. Yes. 4 and the 2a are the third level. Ah, that's what people would think. What do you do? I can go one more step. Can I not get these together? I didn't say I can't. This would be 2 to the 8a is incorrect. Do you multiply exponents with the same basis? You add them. So this would be 4 plus 2a. Okay? You never ever multiply exponents unless it's power to a power. But when you multiply powers with the same base, you add the exponents. Okay, so what would this equal? This should equal 4 plus 2a. Does that make sense? This step, I think, would be the most dangerous for students because I know there's going to be a lot of 8A's there. Okay? But remember, I've never taught you that, so don't do it. Now, I want you to see another way to do it that actually it's like 3 steps. Okay? It's way, way easier than... So if I just erase this so I can have room. Okay, now, so this, could I write this? Let's just work with this for a second. I'm going to bring this down here, and I'm going to go and make it log 2 to 2 to the 4th x squared. Okay, now after I do that, I could make this log 2 to the 4 plus log 2 to the x squared. Okay, does everyone get that step? Those two are multiplying, so I can split them up into 2 logs. Now, why did I do that? What does this equal? This equals 4 plus 2 log 2 to the x, right? What does log 2 to the x equal? This equals a, correct? So my answer is 4 plus and if we wanted to go, we could probably find 3 or 4 different ways to do this one. Okay? So when you're doing yours in the book, yeah, you're going to see, I wouldn't have done it that way, but if you come up with the same answer, that means you did apply the right rules. Be very careful, you guys, that you are not making up rules that are wrong, because obviously you can see where that's going to go. Okay, now this is going to be on your diploma, something like this, because your calculator is not saving you here. If you haven't been showing up to class, there is no way you're going to get this one. And if you are making up numbers for your variables, it's actually quite a long journey to get through this one. Now, the first thing we always want to do, like I've said, is get all the pluses together and then all the minuses together. This is a strategy that will serve you well in a lot of these questions. So I'm actually just going to rewrite it's log b plus log d plus 1/2 log a minus 5 log e minus log a squared. So I always do that step first, and if there was 6 minuses, I would put them all at the end, and then you always get this entire set in brackets. Oops, 5 log e plus log a squared. It's nice because then I get to multiply. Like if there's 5 minuses, I can just take, because I only want to do 1 division in every question. Do you understand? I will always only do 1 division if I group. If you don't, you'll divide, then you'll do the next one dividing, then you'll do the next one dividing, and the next one dividing, and you are going to get it wrong because the more steps you do, the greater chance you have of making an error. Okay? This always makes one division. Students do not do well with division. Let's get rid of it. Now, I'm just going to rewrite this for the sake of confusion. Okay, so I've just taken, the only thing I've done here is taken a negative out of all of my minuses. So do you understand? I will only ever have to do one division. And they want to know, do you know this step? Part of the diploma is getting done. So if you are spending too much time on questions, you're not going to get done. So they want to know, do you even know, like, they do want to know if you're efficient. Now this one here, we will multiply all of these together. So this would be log, oh, no, I can't yet. The bad thing about multiplying everything together is it's got to be log. Okay? So you can never have this out front. This must come up here, and this must come up here. And there's another thing we've done. So step 1, get all the minuses on the left. Step 2, take out the minus. Step 3, do not have any coefficients in the front. Move them up as exponents. So now I'm going to multiply all these together right here, and then I'll multiply all these together here, and then I'm going to do a division at the end. And we're just going to put it in order. This would log a the 1/2 bd minus log a squared e to the 5. Now my division, log a to the 1/2 bd all over a squared e 5. Am I totally simplified? No, I can do the a's. Now, what's 1/2 minus 2? Oh, that'd be minus 1. Negative 3 over 2. Okay? So this would be log a to the negative 3 over 2 b d all over e to the 5. Now, this isn't allowed. You will find there will never be negative exponents in the answer. So you'll have to go log b d over a 3 to the 5 e to the 5. Oops, that's 3 over 2. I like how everyone says yeah after I found it. When you subtract, always put the answer on top. It's a good question. Okay, so there's lots of steps in here. You need to be writing steps down. Again, maybe you don't need them much for this final, but you will love to see those steps when you pull your study sheet out, because now it's time to study the diploma. Okay? So that's it. So we're doing 1 to 3, do the B's, 4A and C, and then 5 to 11. Okay, so you have lots of time. Please don't be talking. And if you get your homework done early, don't bug people around you by talking to someone, because I would like everybody done. Okay, and then remember, Monday is going to be a long ways away. Yep. Some of you probably won't even remember how to get to math class, let alone what we did in math class. So hopefully you have a study sheet that'll help you out.